Hi everyone, my name is Dylan Crichton, and this is my final design video for ECE 5000, and my project was the remote patient monitoring system. So I'm going to go off of my specifications for that I made during my brochure, and these are, and I'll flash them up on the screen here, um, body temperature measurement. So my system will accurately monitor a human body temperature. ECG monitoring. So my system will capture detailed ECG data. Heart rate measurement. So it will continuously track and record someone's heart rate. Real-time display for patients. This will be using a LCD screen and will display the patient's heart rate and body temperature back to them in real time. And lastly, remote transmission of the data. Um, so this will securely send collected health data to a healthcare team for ongoing monitoring, so they can see your heart rate, ECG, and body temperature at a remote location. And this is done using Node-RED, and there's a web link that can be sent to anyone, and they can open it and then view that dashboard. So the next thing I want to talk about is the sensors that I used and the project box that I created to 3D print. So firstly, the sensors that I used included the ECG sensor, which was an AD8232, and that was purchased from SparkFun Electronics. The body temperature sensor actually is just a normal temperature sensor, and that is DS18B20. And that is, like I said, a normal body temperature sensor that we'll use to measure human body temperature by placing the sensor underneath the armpit. And that was completely tested and works as expected. The next is the heart rate sensor, and that is the SEN-11574. And that is a thumb-based heart rate sensor. So you just place your thumb on it, and it'll read your heart rate. The Arduino that I use is a Arduino UNO R4 Wi-Fi. And finally, the LCD screen that I used was a Hitachi HD44780. So yeah, these are all of the sensors that I used. Now the project box was created using Onshape, and this was 3D printed. And the size of the box was 20 centimeters by 20 centimeters by 10 centimeters. And it has 3 holes in the sides of the box to allow for sensors to protrude from the box, and also a bigger hole in the top of the box to allow for LCD connection. So the next thing I wanted to talk about was the circuit details of my project, and it's not a complicated circuit, but there is quite a few connections, especially when you include the LCD screen. So I'll just go over the block diagram to not make it too confusing, and I'll flash it up on the screen here now. But we'll start with the Arduino R4 Wi-Fi, which will provide 3.3 volt and ground signals, and also 5 volt signals for our sensors and our LCD screen. Initially, the body temperature sensor will use 3.3 volts and ground, and it'll also send a data signal to pin D13 of the Arduino. Also, between the data signal and the 3.3 volt signal of the body temperature sensor, there needs to be a 4.7K resistor attached in parallel. Moving on to the heart rate sensor. The heart rate sensor uses 5 volt and ground from the Arduino, and that simply just sends a signal to pin A0 of the Arduino. Next, moving on to the ECG sensors. So we receive ECG data from 3 ECG sensors that combine on the board. and then that gets back outputted to the board through an output signal. Again, the ECG sensor uses 3.3 volts and ground. Also on the ECG sensor is an LD plus and an LD minus, which is a differential pair signal, which basically just tells us if there's a lock detect on our sensors. So it will tell us if we do have the sensors on or if we don't have the sensors on. Lastly is the LCD screen, which will show the patient heart rate and the body temperature of the patient. And this has about 13 wires connected, so there's a lot of wires. It uses 5 volts and ground, and then sends some digital signals back to the Arduino, and the Arduino sends some more signals to it. So the next thing I wanted to go over was the software design for this project. So initially, we have to include a couple different libraries such as Pulse Playground, Pulse Sensor Playground, One Wire, Dallas Temperature, and Liquid Crystal. Pulse Playground is for our heart rate monitor. One Wire is for our ECG monitor. Dallas Temperature is for our temperature sensor, and Liquid Crystal is for our LCD screen. Next, we move on to setting up our different sensors. So setting up our temperature sensor, which is located at pin 13, so D13. Next, we move on to setting up our pulse sensor, which is located at analog pin 0. And then there's an LED on the board that will also flash to our heart rate sensor. Next, we set up our variables for averaging our beats per minute. As I mentioned before, we are averaging our beats per minute over 30 seconds. So these are all our variables to do that. Next, we have to set up our ECG sensor, which it will be attached to analog pin 1 on the Arduino. And we have a storing variable for that as well. Lastly, part of the setup, we'll set up our LCD screen to include some digital pins and some RS and enable pins. Yeah, and then moving on from there, we're in our void setup loop. So this just kind of initializes everything, initializes temperature, initializes our readings for our array of our heart rate data, and initializes our LCD screen. Next, we move into our continuous loop after our setup is complete, and this will continuously run the beats per minute, the body temperature, and the ECG signals. Here we have it to be sent as a JSON type data, and that is because when it gets sent to our Node-RED dashboard, it needs to be in the format of JSON to be read by a certain function node within that Node-RED dashboard. So this setup helps us kind of parse that data when it gets into the Node-RED dashboard, so that we can create the ECG, the heart rate, and the body temperature nodes as required. This here is for the LD minus and LD plus, walk detect plus, walk detect minus on the ECG signals. And then moving on to setting up our LCD screen. So it will print our average heart rate in beats per minute and our body temperature in degrees Celsius. Lastly, in this continuous loop, we'll delay for however long, and then we'll repeat that all over and over again until the loop stops, which it runs continuously until, say, we stop it manually or unplug the device. Now this is just using node-red to view our ECG, body temperature, and heart rate data. So initially to start node-red, you need to just type in node-red into your terminal, which will start up the dashboard, and we'll just wait a second for that to get going. And there it is. So as you can see, the ECG dashboard is shown. And as you can see, there's ECG data showing up on the ECG dashboard. Currently, the body temperature is at 36.3 degrees Celsius, which is pretty normal for human body temperature. And the heart rate value is quite high right now at 230 beats per minute, which is pretty high, but should drop down because my beats per minute is definitely not 230. So there's one thing with the heart rate monitor, that it produces very high and very low values. So one way that I mitigated this was to take the average over 30 seconds of the heart rate value. So then this would, so the value that the user sees is the average over 30 seconds. Also, as you can just witnessed, the ECG graph does reset after 1 minute because the ECG graph gets very compressed horizontally after about a minute and is impossible to read. So we can reset it after a minute so that it resets the graph and that it creates the readability of the graph. Hi everyone, this is the project demo for the remote patient monitoring system. And currently we have a patient that's hooked up to the ECG monitor, the heart rate monitor, and the body temperature monitor. So we're going to get started. And to get started, we just need to type node red into our terminal, and that's going to get our dashboard started. It's going to show our values. So that's getting started. We're just going to wait a second. And here's on our extended screen, just waiting for a node red dashboard, and there it is. So as you can see on this dashboard, we can see the ECG chart on the left hand side, the heart rate value in the middle, and the temperature on the right. So as you can see there, the ECG chart is the values are fluctuating, and that is as expected through an ECG. Also, the temperature is between 36.5 and 37.5 degrees Celsius. which is normal for human body temperature, and the heart rate started off at 50, hasn't changed yet, but should change any second. Also, the ECG chart will update itself every minute. There we go, the heart rate just changed. Because if we don't update it every minute, the ECG chart gets compressed horizontally too much. There we go. And the sensors are not able to, the chart isn't able to be read. So that is updating still. Everything is working as expected. But this is our local host dashboard, so this doesn't provide the remote functionality. But if we go over to this computer, which isn't connected to the Arduino, this is connected through a web link, and this is also displaying our Node-RED dashboard. So the link can be sent to anyone, anywhere, and they could view this dashboard. So this provides our remote functionality. And lastly, we have a LCD screen here on our box that is displaying our heart rate and body temperature back to our patient, so they can see that also in real time, which then also matches up with our dashboard. So yeah, that's the functionality of this system, and thanks for watching. So just to recap, my final design project for ECE 5000, which was a remote patient monitoring system. We started off with some ECG signals, some heart rate data, and some body temperature data, which is then displayed on a Node-RED dashboard, which can then be viewed on your local host computer, which is connected through your USB-C connection of the Arduino. But it can also be viewed on a remote dashboard, which is like a remote computer. And that link is made through ngrok, which is a computer application. And that can be sent to anyone, any location, so they can view that in real time. So that provides our remote functionality for the system. Also, we're using an LCD screen to output heart rate data and body temperature data back to our user that can see that in real time. I will also want to point out that none of this is medically tested, so we can't use this for any medical prescribing applications. All the sensors are relatively on the cheap side, so I wouldn't really trust them to provide any clean medical advice. That being said, based on the past couple videos that I've posted and created within this video, specifically the ones going over the Node-RED dashboard, the LCD screen, and then the final one that shows the full demonstration, including the remote functionality. That shows that all of my project specifications have been hit, and they all work accordingly. There were a couple issues along the way, such as the averaging of the heart rate data and the ECG signal being too compressed horizontally in the Node-RED dashboard, and also the just the visual of the ECG signal in the Node-RED dashboard. So the Node-RED dashboard, the ECG signal comes out a little bit skewed, and it possibly doesn't look like an exact ECG. But in my previous video, I showed that the ECG signal does come out better on an oscilloscope and also in our Arduino IDE monitoring system. So yeah, that's my final design. And if you have any questions, please reach out.